all of a sudden nothing's exploding, nothing's changing colors. And I feel like we're setting them up for failure, saying, you're the best slime maker I've ever seen. You're going to be a rock star in college. And it's just not true.
Welcome back to Demystifying Cosmetics, the show where we unpack the science, strategy, and storytelling behind the beauty industry. Today, we're venturing into the imaginative world of molecular literacy, a concept that could transform how we understand science, starting as early as age 8. Our guest is the remarkable Dr. Colleen Kelley, a retired University of Arizona chemistry professor and creator of Kids Chemical Solutions, a comic book series that brings foundational chemistry concepts to life through characters, storytelling, and humor. With over 30 years of experience teaching chemistry at the university level, Colleen became acutely aware of a problem. Students, even at the collegiate level, were struggling with the basics, like recognizing the symbols of the periodic table. This realization sparked a new mission: to make chemistry fun, accessible, and as intuitive as reading. Her vision led to the Emmy awarded PBS documentary, Comic Book Chemistry, in 2023, and a TEDx talk titled Molecular Literacy for ages 8 to 108 in 2025. Through her comic books, videos, and hands-on activities, Colleen is gifting a new generation of future scientists the tools they need to succeed long before they step into a college classroom. Colleen holds a PhD in chemistry from Penn State University and completed research under Nobel Prize-winning Jean-Marie Lannes as you're going to have to help me with this, the Chateaubriand Fellow?
Yeah, Chateaubriand Fellowship. Yep.
Yeah, okay, at Strasbourg, France. A tenured faculty member and published expert in environmental toxicology, medicinal chemistry, and chemistry education. She has authored 4 chemistry textbooks and more than 30 peer-reviewed articles presented around the world. Welcome to this episode.
Thank you. It's great to be here.
Yes, I'm really excited to dig in. I was telling my sister about the conversation I had with you prior to this and kind of what you were doing. And both of us had a pang of jealousy. We went, we wish that was around when we were younger. That would have been great. So this is definitely very interesting and relevant and really great to be talking about in this point in time, especially with a lot of changes that are being made.
Yes.
So, let's start with the foundations of molecular literacy, a term that you coined. What sparked your idea to treat chemistry as a language with its own alphabet and grammar?
Really, it came from teaching years of organic chemistry and to, thousands of pre-med students who had an A in everything since they were able to walk. And then they get to OChem, organic chemistry, and they're flailing. And it's their very first time where academically they're not successful. And it really made me take pause as to what would impede a student who is motivated, who is well-read, who, for all purposes really wants to do well in this course. Why would they be struggling? And I realized they weren't seeing what I'm able to see. And I thought of those abstract paintings where you have to see the kind of the shape inside the shape kind of thing, and either see it or you don't. And if you can't see something, you can't succeed. And these students were finding workarounds. They were I kept hearing, Dr. Kelley, organic chemistry is just memorization, and it's not. But it has to be if you're illiterate, right?
Yeah.
So if you have a degree of illiteracy, whether you're in a foreign country, and, when I traveled to Israel or traveled places where the symbols were different, I was illiterate. And so you have to memorize some things without context just to get through.
Yeah.
And so those two things really bothered me as a professor, is why are these brilliant students not succeeding, and why are they telling me that they're memorizing something that is really a fluent story? And the word fluent came to my mind, and I thought, okay, well, fluency is language, and that gets back to literacy. So what is it that they're missing? And they're really just not able to read the language of chemistry.
And I know you and I talked about this, and you mentioned that, organic chemistry has always been viewed as kind of that class, right, that weeds out those that won't succeed in a field that requires them to be in that. And that can be very discouraging. Again, I'm mentioning this conversation I had with you because to me, this is very exciting. My boyfriend, ended up going into the career he's in because exactly that organic chemistry was too challenging. And so when you think about what molecular literacy is, why is it just as important as reading literacy in today's world?
Yeah, it's a symbolic language that opens the doors for hundreds of careers, and so that's one reason, but also opens the doors for understanding each other and the world around us. I mean, we are all made of elements and molecules, and we are more similar than we are different.
Mm-hmm.
And if we can recognize that similarity, we're going to be able to bridge divides, foster curiosity, and speak a universal language. I mentioned the language thing because I did my postdoc in France, as you said, and wasn't a native French speaker by any stretch. But when it came to speaking chemistry, I could go to group meeting and they would say, instead of nitrogen, it was nitrogen. So I quickly realized that chemistry is a universal language. And when you are a postdoc in a lab where there's 7 different nationalities speaking all their native tongues, but we come together for group meeting, we're all speaking the same language. So there's a universality to it. There's an understanding of things that I am now thinking of basic human rights, like understanding nutrition, health, environment, and then obviously then the ability to pursue a career that fits your purpose instead of having to dodge to another one that's tangential to your purpose.
Yeah. And when you think about how maybe we've not been successful in having chemistry be curriculum for kids, what do you see as defining success when it comes to teaching chemistry to children?
I would say defining success would be for it not to be siloed, for it to be a literacy unit. So, for example, when they're reading my comic books and doing the activities, how is that different from when they're reading their, whatever Junie B. Jones book and answering some questions about Junie B. Jones or whatever book they're reading at the time? How that those are seamless activities that mesh together instead of are siloed. So, and I'd like for chemistry to become that realm for success, because if it's just siloed into the place where you go to make slime or, combine baking soda and vinegar, we're not getting anywhere with that. We've tried that for 40, 50 years and we're not getting anywhere with that.
Yeah.
So let's try something different
Yeah.
and let chemistry be on the literacy side of things, because of the fact that the elements are letters we're putting together to create a language.
And you mentioned that, this idea that students felt they had to memorize certain things, memorize a chemical reaction, right? Or memorizing the periodic table. Were there other moments during being a chemistry professor that made you realize that students were really struggling with what seemingly felt like foundational concepts?
Yeah, I remember in office hours, I had, and this happened many times over my career, a student would say, well, I don't understand what this stick is. And I'm like, what stick did I draw? And it was a bond,
Yeah.
right? So when you draw a carbon and then a hydrogen, you might draw a line up, or you might really draw what looks like hieroglyphics.
Yeah.
And so when they could not see, they thought they could not see when I was drawing a structure like this, that's pentane. And see the carbons and hydrogens, and that there's 2 electrons between each of those 2 carbons, and all the things that I saw. And they're like, what are these sticks? And we're, 6 weeks into a course. And, and then it becomes like, wow, I have really missed the boat with this student because they can't see what I'm seeing.
And is the expectation and the opportunity, I guess, that you saw where a student may come to you 6 weeks in and you realize, oh, I really needed to start with foundational items, but I have to get them from A to, here. I have to have them run a marathon in, a Kenyan
Yes.
professional athlete speed. Was that really this kind of aha moment where you thought, that is too far to bridge, but what isn't is maybe this introduction to a younger audience?
Right, exactly. And when I started working with younger kids and seeing that, none of the chemistry that we teach in college until maybe the junior, senior level, 400 level, requires anything more than basic math and, pattern recognition and literacy, those kind of skills that they already have. But like you said, to cram it in a short amount of time, that, you can't train for a marathon in 6 weeks.
And were there any misconceptions or barriers that you saw, other than this, kind of lack of exposure to college level chemistry, that also helped you to, figure out what your comics really needed to aim to dismantle?
Yeah, it's more subtle though than something that came to me directly from my students, but it's a community wide and maybe K through 12 paradigm where there's so much emphasis on hands-on learning in the sciences and trying to get that for and I understand how that helps with a brain's development. And what I do know is that when you get to college, chemistry might be a 5 credit course. 4 of those are lecture. That's literacy. So
Yeah.
80% of a passing grade, which is, most likely for what people really need is an A or B. A C kind of doesn't really even get you there. So, an A or a B, 80% of that grade is literacy. And so to dislodge this, importance on hands-on, and they do hands-on in K through 12, and then they get to organic chem lab, and it's clear and colorless, and it might be in an NMR tube, and it's data, right? And that's all you do for lab. And all of a sudden, nothing's exploding, nothing's changing colors. And I feel like we're setting them up for failure, saying, you're the best slime maker I've ever seen. You're going to be a rock star in college. And it's just not true. And I wish we would just stop and focus on these fundamentals. Can we teach them IR and NMR in high school? For sure we can, right? It's interpreting data. So there's so many skills we can bring down to the lower level, and so that they can get into then meaningful undergraduate research programs too, and start the exciting lab work. But just this notion that, reading and writing and analyzing data isn't important is just an abomination, really. Scientists always are reading and writing and analyzing data, especially if you're a PI, you're not even in the lab.
Yeah.
So I think it's really important to really show what science is and what science isn't. And no longer should we have the white lab coats and the crazy hair and the explosions. If the COVID vaccine blew up, that's not funny. That's not fun.
Yeah.
Right? Like, it's millions, billions of dollars in development. So, this whole notion that chemistry blows things up and you have to wear a lab coat and look like Einstein needs to go away and be rebranded.
And it's interesting you talk about the hands-on learning, because I think I've been using that almost as a misnomer, where I've said, well, I've got, the most I've advanced, I think, in my fundamental knowledge has been in careers and what I call, quote unquote, hands-on. But you're right, the energy wasn't, how do I run an NMR tube, right? That's easy. You drop it in there. It was, how do I look at that data, right?
Yes.
And so, maybe there is this kind of misconception, right? That you're like, oh, well, it's hands-on, hands-on. The only hands-on thing I did was climb up on a ladder and drop an NMR tube into the reactant. What really was the learning point was then getting that data and saying, well, why is it different than the blank? And, does this show that there's some sort of polymer that's formed, those kind of things. So I see where, this actually, kind of notion of hands-on learning can be confused sometimes with, like, actually, no, it's that not the act of doing, it's the act of taking the data and creating the story and understanding what's happening. And leading into storytelling, what is your approach to taking maybe abstract chemical principles and turning them into characters and adventures?
So this all started when I was teaching organic, And like you said, when I realized I had to get many students caught up, so how do I get them to see what I'm seeing? And at the time, I was a new mom, so I had lots of Winnie the Pooh characters around, and and some other access to Pixar movies and
Yeah.
things like that. And so, there's a reaction in organic chemistry, a substitution reaction. So we call it SN2. And there's groups that have to leave while something else is substituted, and they leave at different rates with different abilities. And I just said, okay, well, Fluorine's like Piglet and is just going to cling on and be a very terrible leaving group because Piglet doesn't like to go off on its own. And Pooh is more like Bromine, big and puffy, and kind of wanders around the 100-acre woods all by himself and could care less about being alone. Um, and then just kind of like would constantly, whatever the Pixar movie of the year was, kind of, I did a lot of Shrek.
Oh, nice.
And,
Okay.
and it's just kind of find these stories until I finally realized that I was falling short on some things and needed to make up my own characters.
Yeah.
But as long it's a razor thin line to do that in a classroom, because you don't want them to answer the question with, those characters.
Yeah.
You'd like them to talk about polarizability and
Yeah.
electronegativity and the intrinsic chemical properties. But it's a start, at least, where they can make sense of a hierarchy of patterns and things like that. So it was kind of this amalgamation of desperation, access to content,
Yeah.
and how can I get them out of memorizing and into a little bit of a flow. When there's characters involved, you can predict a character, so there's a prediction instead of memorizing.
Yeah. It's funny. My organic chemistry teacher, his what he brought for his humor and an analogy was he would call carbon bonds. He'd say, "Smoke them if you got them," because it was like, a time where he was like, when we used to have cigarettes, you smoke them if you got them. And so anytime, like you'd be doing it, and you're like, okay, I got to fill these. Here's a carbon, it's got to have a bond, so smoke them if you got them. And those things stick with you. To this day.
Yep.
That's still something. How, God, 20 years later, that has stuck with me. And I think when you started to see success in maybe the college students, how did you think about the role of visual storytelling and humor, and how that maybe would play into improving retention and comprehension in a younger demographic? Because you do teach at a younger demographic now, correct? Yeah.
Correct. Yes. Originally, it wasn't intended for a younger demographic. So I was started to kind of create a textbook, a Gen Chem textbook, with with my stories integrated into it. And as I pitched that and sent queries out to different publishers, it was turned down unanimously. No one got the vision. And so even as I kept writing, and so what I was doing is I was taking like the traditional, maybe Chang or whatever Gen Chem textbook, chapters 1 through 10, what's taught in first semester, and just scaffolding that in these stories. And then I started kind of on another level, just out of a hobby, writing children's books. A friend of mine, one of my best friends, is a children's book author and professor at the University of Arizona in children's literature. So we started collaborating on STEM books together.
Yeah.
And I was going to workshops on writing children's books, and years of this, the pandemic hit. I was learning about word limits for different age groups. And really, the only thing that was going to fit for what I wanted to do was a comic book format. Nothing else fit. And then I said, okay, now I have to learn how to write a comic book. And what was happening was the characters were super fun and cute and funny. The comic books also had that kind of playfulness. And I think there was the assumption automatically this is for a younger audience, when in fact it was scaffolded against the first 4 comic books are the first unit in any Gen Chem book.
Yeah.
And that's my molecular literacy bundle. So it's this kind of weird thing where the intention really was to help high school and college students, but then the look of it and the feel of it came around to a younger audience. So then my same friend that I was co-authoring with had a 3rd grader at the time. And I said, all right, okay, Olivia, try this. So she tried it and she was getting it. I said, okay, let's try this. And it was COVID. So all of my friends had elementary school students at home. So it was really easy for me to get the material to them and Zoom with them and collect a ton of data on the efficacy of it with ages 8+.
Yeah, I was going to ask if, yeah, there's obviously the feedback loop, but in learning about, let's say, again, word limits, or even in the comic book format, are there principles that, you knew you had to stick to? Like, this story has to have a beginning, middle, end. I have to have a heroine or hero character. I have to have a villain. I have to do character development. Were there elements of storytelling that you learn as like foundational English concepts that you really had to kind of say, okay, how do I maintain this, but also integrate, these concepts at a level that can be understood from ages 8 to 108?
Yes, yeah, those dozens of workshops and conferences that I went to in children's lit definitely helped with that. I would say that I still tended out of necessity to violate some of those principles. My comic book artist, sometimes I had to explain to him, I know this is a big bubble, Jonathan, but let's do it. we gotta do it. And so, I had a comic book artist who was a veteran. He was the creator of Stitch for Lilo and Stitch.
Oh, nice.
So he was super helpful in mentoring me, 6 panels, no more. 6, 4 are good. 3 and 5 are problematic sometimes. We can do a 1 if we need it. And just really working with me on trying to get it in comic book format and to have that story arc and all of the above. And then I was also influenced quite a bit by Highlights magazines.
Oh, yeah.
Because I had them as a child.
Definitely.
They were, and so I kept thinking they can only read so much, then I need them to implement. So there's puzzles in the middle of each comic book. So as they finish something, they're like, hey, help Poppy and Ray do this to move the story forward.
Nice. Yeah, I was going to ask because part of like even learning a language, right, is practicing that language. And so, after they finish this series, is there any continuing or ongoing support that you think is missing in terms of, okay, they've learned the concepts now and they're applying them appropriately, but they need to consistently do that in order to, get the confidence and also continue to grow and expand in this area, this field?
Yeah. So what I realized is that the stories themselves are engaging with the students. They want to just blow through it, right? They just want to read the story. They want to skip the puzzles in the middle and get to the end because they're mysteries. So they want to see what happened. And there is an arc and there's a buildup and excitement. And with my curriculum, so the comic books are here, and then I've got a whole curriculum. With the curriculum, I give, the teachers or the parents or whoever's helping every lesson guide that has like every 5 minutes something to do. And then I've got a separate, it must be 200 and some page. It's like one of those big fat activity books you would get at Costco to go with it.
Spiral bound. Yeah.
Yeah. So you get, you'll get to a certain point and you need to do this many Poppy's puzzles, or you need to read Ray's rules or do Granny's game. So you might play periodic table twister at this point. I also have a reading guide. So back to the literacy part of it. There's a reading guide with reading prompts. Yeah. So, on page 1, answer these questions. And I found in my own classroom, when I'm using the reading guide, it slows things down to a level of learning and comprehension as opposed to just seeing the story unfold. And so I can ask some pointed questions and then there's a level of writing where they need to write. So, and it's all handwritten. These are all paper products.
Okay, real quick. Raise your hand if you have dealt with active instability. If you have ever opened a jar of retinol cream and smelt an off odor, or noticed your formula went dark brown, chances are you are dealing with active instability. It's never fun when the formula you've been working on goes south and the due date is only days away. That's why we've encapsulated the trickier ingredients to work with so you can kick the stability struggle to the curb. From retinol to vitamin C, we make it easier to work with those ingredients that typically give you that 3 p.m. headache. The cellulose shell shields the active from outside exposure. Things like air and light that are likely to cause active breakdown. giving you the power to create stable and effective formulas without the trial and error. Ready to quickly create effective skincare formulas? Discover Tagra's Cellucaps line by going to tagra.com/cellucaps. So, have you encapsulated yet? Now back to the show.
Because this early exposure can affect a student's success, and even in first talking to you, I really needed to reset my own expectations, because you had mentioned that you have, I believe, fourth graders balancing equations, correct?
Yep. Mm-hmm.
So, for those listening in, where do you think, so this is to be integrated, when a individual is able to, basically read, so
Right.
having reading comprehension, but, what degree of proficiency can we expect, at these different age groups as they progress up to high school?
Right. So the first 4 comic books get through, well, actually, they can get up to balancing chemical equations. So they can write ionic compounds, whether they're complex or simple ionic compounds. Look at a double replacement reaction, for example, and balance that. So it's where I've noticed where the wheels start falling off in Gen Chem is polyatomics, right? All of a sudden. And so I really, the 4th comic book is heavy on polyatomics, showing them as an individual character. So like carbonate is a character. Mm-hmm. So they know that you can't separate the carbon and for the most part, you can't separate the carbon and oxygen, especially in a double replacement reaction. You keep those together. Certainly in decomposition reactions, there's something separate, but, just that notion of what polyatomics are and how to treat them, what are parentheses, what are subscripts, what are superscripts. So you can get a student up to that level, and that is what I would call like if you took French 1, So you're not fluent,
you can ask where the bathroom is. Yep. You can say your name.
Yep. So it and my hope is, I mean, we have a series of 10 planned. We're seeking funding. We're seeking development funds for the remaining 6. So the hope is when they're done with the series and then have done all the activities, that it's the equivalent of 1 semester of freshman chem.
Oh, nice. In kind of this, I guess, gamifying of learning, right? What is the feedback that you've gotten from kids, teachers, or even scientists about this impact that they're seeing with the kids' chemical solutions?
Well, it's really exciting. And I was just at the American Chemical Society meeting in San Diego and gave some talks. And I was in the talk where predominantly my audience was AP Chem teachers. And I think there's this kind of notion, well, this doesn't apply to us. And then after the talk, each one of them said to me, this applies to us more than any of the other talks. Yeah. Right? Because they see the stumbling blocks and know that if their students are solid in molecular literacy, then all of a sudden when they get to electrochemistry, it's not going to be as hard. Yeah. And you can spend maybe more time on electrochemistry. So the feedback, for me, that was really unexpected for these AP Chem high school teachers to say to me, hey, this is awesome, and here's why, and we see the vision. And then I get notes from parents. A lot of homeschoolers use my curriculum, and they say that it saved them because they didn't know what to do with chemistry. And they didn't want to buy a bunch of stuff. They didn't want to buy the kits. And so they're seeing that, my focus on literacy and how important that is really is doable for homeschool. And then the kids themselves, I have some great pictures of kids in my own classroom where the one thing they do, it's so funny. And I took a whole bunch of a video of this. When they get the comic books out, they're no longer have their butts on their seats. Yeah. You know how kids get up and then they put their nose on the book and they're hunched over like this. Noses are touching every book. And it's so funny to me to watch like the body language. And I took that picture and my son said, yeah, that's how you know kids are really into it when their butts aren't in the seat anymore. Like they break all the rules of sitting in a desk and have to get as close as possible. And then they don't move from that position until I tell them, hey, you guys have to go to, Spanish or whatever class they have next. And they don't want to stop.
Yeah. When you're creating these stories and trying to deliver concepts, how do you think about character development? How did you come up with like carbonate, let's say, and what were the attributes that you felt you needed to give, this character? And how does that translate, I think, to a little bit of a combination of inclusion, so making people feel like, oh, I resonate with this character, or this character looks like me, or and maybe even the friction between this character looks like me, I resonate with it, and also I need it to be, uranium or
Right.
something not pleasant. How do you balance that kind of dichotomy?
Yeah, so I'll use there's a band called the Heavy Metals
Nice,
that I have,
nice.
and I made them all aquatic type species, fish-like, because I was thinking about, a lot of people know about mercury is in fish, right?
Yeah.
And so you usually tell pregnant women not to eat raw fish. You think about the toxicity of puffer fish and what that is. And then of course, lead is, can be in like the Flint, Michigan. So I thought about heavy metals, and I thought, an aquatic environment seems to kind of fit this heavy metals. So all the heavy metals are fish-like characters. And so the lead singer is Led Z, and she's this kind of jellyfish hybrid between Mick Jagger and Janis Joplin. And she's an old rocker that's all white and gray, that's got kind of this like puffy hat on and bell bottoms and puffy shirt and a big belt buckle that says PB on it that's square.
Nice.
My characters are very Seuss-like.
Yeah.
And I did that for inclusivity as well, because nobody's going to look like my characters.
Yeah.
Right. So nobody looks like a gray rocker jellyfish that, yeah. And a lot of my characters don't have genders either. So I have a character, Red Rusty, that's just this big red donut that's a big red blood cell. And half of it is iron +2, the red, and the rusty part is iron +3, and they're two-headed and they've got legs. And so again, most of my influence is, what do I see when I see an element, and then making that. Sulfur is just simply a yellow puffball that looks like a minion with one eye in the middle. And again, no gender for that. So I'm not sure if that hits inclusivity, but it certainly hits imaginative creativity.
Sure.
That kind of world where, you're not seeing yourself, but you're also not seeing others either.
Yeah. No, that is definitely a positive. And you mentioned that, homeschooling, teachers, parents, caregivers have been, really adopting these. In terms of, here in the US, it's not uncommon for a grade school teacher to have to be that subject matter expert in everything, right? You might have gone to school for English, but you're going to teach English, math, now chemistry. Do you see these tools being helpful for those teachers and also that journey and development to be able to teach their students?
Yeah, that is my dream and my hope. And, because I am now in a role as an elementary school teacher, I see the elementary school teachers in my school, and they're teaching from National Geographic. Why don't you just pick up my books instead?
Yeah.
Right. So they do have STEM units in their English language arts units. They're reading, they're writing, and they do that all the time. They'll learn different things. Maybe they'll have a space unit where they're reading. So they read nonfiction and they read science related content. Why not just read my comic books?
Yeah.
It's the same amount of time. I've given them all the tools I have 108 pages of detailed lesson plans. We've got card games. We have bingo, twister. So I've modeled it after what they would have used anyway for maybe a National Geographic unit or something like that.
Yeah. Okay. And for, real world applications, so let's say somebody gets this foundational education, but they don't go to college maybe for a degree that requires chemistry. They're maybe in the humanities or something else. How do you see this background under this common language, this foundational knowledge, really helping consumers to navigate things that they encounter in their daily lives, like cosmetics, for
Yeah.
instance, or food?
Yeah, I've definitely taken a deep dive into cosmetics myself prior to doing all of this, as a medicinal chemist, toxicologist, kind of bordering on this. And what I brought to my students when I was teaching organic chem, especially in the organic chem lab, is the oxidation of vitamin C. And what is vitamin C? And why is vitamin C in cosmetics? And we all know it's water soluble. We know how quickly it can be oxidized. And how is it stabilized in these products? Why is a water soluble molecule like vitamin C in a cream? What is the palmitate derivative of that? How are we making it lipophilic when it's water soluble and polar? And why are you spending this much money on a product? Look at the label and know, at least know that what vitamin C on a molecular level reads like, right? So from a molecular literacy point, vitamin C is ascorbic acid, but also what's ascorbyl palmitate? What does that mean? So what are the different ways that additives to cosmetics for enhancement really bring the level up, and what is that, and what are you buying? And when I bring that up, I also bring up a lot of my students are just shocked when I talk about protein powders and the fact that you can't eat a protein. And like in your stomach, it goes to individual amino acids and then gets distributed as needed, right? So you're consuming a protein powder just to get more amino acids, right? And they're just shocked that, you're not, eating creatine and putting it on your muscles, or, like
Yeah.
that, so I do go into a little bit of, I think with molecular literacy, you can talk a little bit about pharmacokinetics, pharmacodynamics, metabolism, like real metabolism, like how things are digested and what's the difference between digestion and denaturation and all of that. So I think there's some really handy things that most consumers would want to know.
Yeah. And then taking even a step back, I know we've talked about how a lot of times the sciences and how they're taught are very much, like you're going to take bio, then you're going to take physics, and there's a lot of overlap. And we talked about how, having this fluency in chemistry can really help with things like photosynthesis, right? And teaching photosynthesis. Are there other like common through lines that you see in terms of, well, if they're learning about chemistry as 8-year-olds, they're also going to understand X, Y, and Z concepts much easier? Have you made any of those associations or observed any of that?
So are you talking more at the younger age, what
Yeah.
they could understand better?
Yeah, and then like how they're applying it, right, to what they're seeing around them, to other areas that they're learning.
I really think that it's interesting what the misconceptions around water are, right? So I have my kindergartners drawing hydrogen bonding, right? So we do there's an activity where you put drops of water on a penny and you get to see surface tension, but then we talk about hydrogen bonding. But I think when it talks to even phases of matter, solid, liquid, gas, we can teach it with intermolecular forces, right?
Yeah.
And then we can establish that. So again, it's a neural pathway and a picture in their mind. And I have my kindergartners, 5-year-olds, understanding hydrogen bonding. They can draw that and see that and understand that that's, I use the word Velcro. It's like molecular Velcro. It's sticking. Yeah. And then I think when they get to the higher levels and are, maybe in physical sciences talking about the water cycle. What is water? Water really is so fundamental and so complicated, right? With acids and bases. I show them what an acid and base, a weak acid and weak base is with transfer of a hydrogen and what that is and what then acid rain means and all of the above. So I think for me, water is so important, and water is never really taught as a whole class, right? From just the bonding, the bent structure, it's, sp3 hybridized, all of that, the hydrogen bonding. There's so much basics of water. If we understood, then all of a sudden everything else I think would open up in biology, biochemistry, environmental science. Water is just everywhere. Yeah. So I think that's a really powerful contribution that this can make.
Yeah, that's interesting. The example you gave during COVID, my son was in the 5th grade, and it happened very rapidly, and a lot of teachers were ill-equipped. There wasn't even immediate Zoom kind of education classes. It was, okay, we'll just assign homework and hope that you're doing it. And so I got a bunch of parents together, and I was like, well, let's have these kind of video learning sessions on whatever you are good at. And I actually have my undergraduate in environmental science. And so what I was very surprised to learn was kind of that lack of exposure that my son and his classmates had in terms of what, global warming and kind of any of these concerns with environmental conservation were. And so it was, something that I introduced, but I also felt like I had to do in a way that was, like almost too basic for them, because they didn't have a background in terms of understanding acid rain and the impacts and why, it's related to industrial pollution. And so, when you think about that, and the kind of impact that I saw, in terms of just my son, where they're like, oh, now we're aware of this thing. How do you think that could potentially impact adults in terms of making conscious decisions when it comes to sustainability or environmental awareness? I know we share common people we know within the green chemistry space, right? Who are really trying to promote, well, you can only create safer products if why they aren't safe to begin with, and are, have different options for evaluating toxicology and kind of how that end of life, what happens to it. And so how do you see this, basic molecular literacy really impacting and influencing consumer decisions or ability to do so to promote environmental awareness and green chemistry?
Yeah. So one thing that's always struck me with, regardless of age, is this term carbon footprint. And if you ask, if I were just to be a reporter on the street and ask what a carbon footprint is, and I've done this, and again, this is, I'm searching for research, not for any kind of judgment. But you do get a lot of notion, like there's a soot footprint. Yeah. Like literally you stepped in, like, I don't know, coal, and then put it on the ground, and it literally is a black footprint. Yeah. And so we use these terms, and they become mainstream without any kind of foundational understanding about on the different forms of carbon in what constitutes a global carbon footprint, if you will, and what does lowering your carbon footprint mean, and what's the difference between methane and carbon dioxide, and I think there's just some really fundamental issues that would be really helpful for problem solving, because I think when we get more of a heterogeneous bunch solving problems, non-scientists, right, but give them some understanding of the world around them, right? We may get some really novel solutions to problems that we and our world would never have thought of. Yeah. One thing I've been impressed by, I listened to some podcasts, and some non-scientists have really, really, really done a great job with explaining science, because they took the time to learn, whether it's about a carbon footprint and what that is, whether it's about, PFAS. And so some of these hosts on these podcasts are, attorneys or, endurance athletes or whatever they are. They care greatly about the environment enough to be self-taught to a level that is really impressive. So that also shows me that it can be done at an older age.
Yeah. And this might be a commentary on American society, but there has been that evolution, right, of disinformation, misinformation, and how it ties into political views. But how do you see where we are currently in the U.S. for education with chemistry compared to the rest of the world? Is this a global issue where just everyone really sees chemistry as not something that needs to be integrated at this level that you're proposing, or is it unique to the United States?
The feedback I've got from whether it's been on podcasts that are international from New Zealand or Australia, UK, India, other places around the world, Canada also, is they're definitely more open to what I'm doing. They're less tied to standards and more willing to explore. Okay, yeah, we know we don't have a standard related to fourth grade balancing chemical equations. However, could we now have one? Could that be a thing that's really important? So I find it's an openness and a more excitement when I go abroad, as opposed to, I certainly have a lot of support here in the United States, that's for sure. But I get a lot of pushbacks from schools that just, public schools are like, yeah, no.
And is that because everything is tied to a standard where, that there doesn't feel like there's room for something that isn't within, a matrix curriculum, that it's just seen as fluff? Or, have you been able to kind of like pull out and like why there's that pushback in terms of that lack of openness from a lot of public school educators or administrators?
Yeah, there are several different reasons, and they're all good. I mean, I once had a principal say to me, if I can't get them to read, I can't teach them chemistry anyway. So, and I'm like, fair enough. That's a really good reason. I would much rather have readers. So let's do that first. And, so if we have a school where they're just struggling to get plain literacy, and that principal is making that the priority above everything else and putting all the resources into that, I'm going to support that 100%. So it really depends on the demographic and the school situation. Some of it is, some administrators and teachers are really, really tied to standards, and, they want to be absolutely sure that if they use this, that there's going to be a standard that they can check the box on. And that may impact their funding. So again, they have really good reasons for resistance.
Sure.
So it's not that they're not resistant theoretically, but in practice, then they're just, in some cases just have bigger things to tackle.
Sure.
And then, the teachers themselves is the one that I think I can get to a little bit better. They just lack the confidence. They were told they were bad at science and math.
Yeah.
And that has to be dislodged. Try again.
Yeah. Yeah. When we spoke, you gave some pretty alarming figures in terms of individuals that fail organic chemistry, but also those of certain color or racial or different ethnicities, that really it expands even into chemistry when it comes to discrimination and access. How do you see in the future directions for kids' chemical solutions helping to try to bridge or make this more accessible? So, in the instance that you gave with literacy, oftentimes schools maybe that are underfunded or are in a high turnover population, they struggle with literacy. And so, how do you see fitting in this curriculum as part of, if it's access for everybody, especially when you do have challenges like, really needing to focus on basics for some schools that may be, underfunded or really struggling in one way or another?
I think the accessibility point of what I've created is because the only skill necessary is, a second grade reading level. So I think a fifth grader, hopefully, even if they're reading at a second grade level, could still access these books. My dream is for libraries nationally to pick these up so they're free, right? And so, or after school programs, or, if they're in like Boys and Girls Club or, Big Brothers, Big Sisters, some mentors pick them up. So that there's this informal access to molecular literacy that doesn't necessarily have to be tested in a school. ideally it's best if it is, because the whole curriculum gives you a much better foundation. Is it doable? Can a fifth grader go to the library and check out the book? There's enough puzzles in the middle. There's enough textbook kind of things in the middle that they could do and continue the program for sure. So I'm really looking at those alternative ways of access to underserved communities and how those kids could get access to these books.
And is there currently any sort of online format? I know for my son, if he doesn't have his laptop at school, then, nothing gets done because everything is through like portals or, these different kind of emerging programs. For the future direction, have you considered or are you looking at really kind of making this accessible completely, virtually?
I am. I originally I would have 3 years ago I would have said no way. I really was anti screen time after the pandemic and learning. I had to teach organic chem at the time at 8 a.m. to 200 students who were all black boxes in my screen, right?
Yeah. No one responds. You get no feedback. Yeah.
And then I had to flip all the labs onto online labs, and I really had some traumatic responses, I think, to having to adapt all of everything I've ever known to online. And I thought, this is my passion project. There's no way I'm doing. I'm like, they're going to have good old fashioned cards to play card games. They're going to have periodic table twister. They're going to have pencil and pen and a hardcover book. I'm coming around from that, and I'm seeing that an online presence could be helpful. So it will also lower the cost. Again, library is free, so library is my preferred free way to do it. But we can also provide that. So I'm working with my publisher to what does that look like to create an online course with everything that I have in it, and how would that look to just access more learners. So I've kind of gotten over it, but I the reason that it doesn't exist now is because I dug my heels in for so many years. And no way. So everyone has to get it by mail.
Yeah. I mean, they've done research, right, where there is a connection between writing and certain brain development that is necessary. And so, it is alarming to some degree that everything in school happens now at a computer. And so it's great that we still have some ability to kind of, have tactile interactions.
Yeah.
So, before we wrap this up with the final question, I'd love if you'd let the listeners know where they can find more information regarding the workbooks and the kids' chemical solutions.
Sure. Yeah. My website has everything. It's kidschemicalsolutions.com. And that'll give you a link to some background research, all the products that we have available. The PBS documentary that won an Emmy is on there. And pretty soon my TED Talk will be up there. It's not available yet, so you can see. And in my TED Talk, I spoke to what we're speaking about, but really gave a lot more background in a storytelling format of what molecular literacy is. So it's all on my website, and and I'm also available if your listeners have questions.
Awesome. And I guess as a final closing question, what advice would you give to educators or professionals who want to communicate science to be more playful and effective, much like what you're doing in educating people? How can adults, educators, professionals start to communicate science more playfully and effectively to non-technical stakeholders?
Yeah, I would say put yourself in their shoes first. So there's this notion of the beginner's mindset. It's really hard to get to when you've been doing this for so long, but try to get to a beginner's mindset so that if you're planning a lesson that's story-based, if you were listening to it for the first time, would it make sense? And would you be able to learn from that story? So really, or test it out on an audience first, and say, and see if you're hitting your learning objectives with that story, and if they're seeing all the things first. But it's really important to go back to that beginner's mindset, just so that you can see if your story is actually hitting the mark or you're telling a story just for the story's sake. And the other thing I guess I've learned is personal stories really resonate with any audience. So if you have a personal story that you can tell, in my TED Talk, I talked about my experience as a 7th grader going through the 3 Mile Island near nuclear meltdown and what that meant for me as a 7th grader, where, only a couple miles away, we were about to have a nuclear meltdown.
Yeah.
And what that meant as, an 11-year-old with braces, like what's happening in my community.
Yeah.
And so these personal stories, and I think we all have personal stories that can help with learning.
Yeah. Well, great. Thank you for being on today. This was exceptional. I appreciate your time.
Thank you. Yeah, it was lots of fun.